In the previous lesson, we made some modifications to the model. In this lesson, we will create the Sari pharmacokinetic model. Heta project is an initiative for the development of infrastructure for modeling in pharmacology and system biology. The project brings together Heta language, Heta simulator, and Heta compiler. In this lesson, we will use Heta compiler. Compiler is a software tool for the compilation of Heta-based QSP modeling platform. We will use it to create a sirolimus pharmacokinetic model, but at the beginning, we must learn how it works. Heta compiler compiles models files from the different formats and exports them to another. Modules can be a part of a big model. For more specific information, you can watch Heta tutorials at Heta project homepage. Installation of the program is performed through the console. Node.json must be installed prior to Heta compiler installation. You can install Heta compiler via npm with this command, or install directly from GitHub. Heta is a base command that prints information about tool and available options. Heta helps does the same. Heta build is looking for index Heta file. Index Heta is a central file of a platform. It contains link to the model parts or contains model written in Heta language and export formats. If you want to make a platform from scratch, Heta provides Heta init tool for creating a modeling platform template. As soon as we want to make project with additional submodel, we must initialize new platform. We will use Heta init in the project folder. After running the command, we should answer a few questions. We can press enter to make a default name or ID. This is a unique identifier of modeling platform. Here, do not use spaces. Nodes helps people to discover your package. Substantial changes to the platform should come along with changes to the version. License identifier and turn off or on the options. In file types, choose Heta plus Excel. This option creates a template of Heta Excel file. Based on this template, we will create sirolimus pharmacokinetic model. We will write it in this format for the further integration with the exported IRT template. Now, platform.json file and source folder have appeared in our project directory. Platform file is a default declaration file. There are properties in declaration file which do not change compilation process. They can be used for annotation of a development QSP platform, for summarizing annotation, and auxiliary information. Source folder contains these files. Index Heta file will be used in the next lesson. QSP units contain units that are used in this project. There is also a file table Excel. It contains a template of a model. Here we will write the sirolimus pharmacokinetic model, so name it PK Sari. Open it in Excel. Newly developed or pre-developed models should use the same IDs of equation, functions, and parameter as IRT templates. If the records with repeated IDs are present in IRT templates and additional models, in the next step, only one record will be included into the merged QSP platform. The record coming last during Heta compiler reading. A model describing sirolimus pharmacokinetics was created as a two-compartment model with linear clearance. We add a new compartment subcontinuous space, 1 liter initial value. Plasma we already have in neutrophils model. In species list we add sirolimus in SC and in plasma. The initial value is 0 for both. In reaction list we will write the next rows. Expressions for absorption and elimination. In records, we must write an expression for monoantibodies in plasma. As a constant list, we will write base constant for absorption and clearance. These parameters were fitted to describe experimental pharmacokinetics data. Also, we must add volume of distribution of sarilumab and modified release dosage. So now we have sarilumab model. At the description, you can find educational support files and compare what you got with this sample. At the next lesson, we will merge sarilumab PK model and neutrophil model together.